Hi guys! So welcome to the third lesson, which is on geometric definitions and two-column proofs. Not gonna lie, this lesson is not super exciting, so I brought my dog in. But this is gonna be called the axiomatic system of geometry. So we have two learning goals. One of them is to distinguish, which means tell the difference between an undefined term and a defined term. The second one is going to be use properties of algebraic two-column proofs. So we're going to throw back to last year and talk about some proofs of algebraic equations. So let's get started. I'm going to move my face around. So geometry is an axiomatic system. That means that from a small, basic set of agreed upon assumptions and premises, an entire structure of logic is devised. So that was a lot. Basically, it's saying geometry was created from very small agreed upon assumptions or guesses. For my gamers out there, many interactive computer games were designed with this kind of structure. So a game may begin with a basic set of scenarios, and from these scenarios, a gamer can devise tools and strategies to win the game. Okay? So in geometry, it's necessary to agree on clear-cut meanings or definitions for words to be used in a technical manner. Okay? So for a definition to be helpful, it must be expressed in words whose meanings are already known and understood. Okay? So let's take a look at these two definitions. A fountain and I don't know how to say that word, a gauge. And so I want you to tell me which of the definitions above is easier to understand and why. So press pause, read those definitions, and then jot down which one is easier to understand and why you think so. How many of you guys thought a fountain was going to be the easier one to understand? I did, because we all know what a fountain is. But actually, the gauge definition was way easier to understand, and the reasoning of that was because we knew the words in that definition. We probably don't know what a roundel is or a berry of wavy, six, argent, and azure. We don't know what any of that means. So just because we know the word a fountain doesn't mean I can understand what it is based off that. However, I can understand a belt that is worn over the right shoulder used to support a shield. So basically, if the words in the definition are easier to understand, that's going to make the definition way easier. Okay? Moving on. So, move my face. For a new vocab term to be helpful, it needs to be defined in words that have already been defined. For first, definitions used in building a system, however, cannot be defined terms of other vocabulary words because no other vocabulary words have been defined yet. Basically, all that's saying is we have to have a starting block definition to build more words from. Okay, so in geometry, it's tradition to start with the simplest and most fundamental terms without trying to define them, and use these terms to define other terms and develop a system of geometry. So the fundamental undefined terms in geometry are a point, a line, and a plane. So from those three undefined terms, we can create more definitions and more fancy fun things based on just those three things. So we've seen array before. Maybe you haven't seen collinear. Maybe you haven't seen coplanar before. But I want you to try and define each of these three terms. You can use the word point, a line, and a plane if you'd like to. Okay, so let's look at an example real quick. The term line segment can be defined in terms of undefined terms. So the definition of a line segment, which we all know is a line with the 2 points, it's part of a line, bounded, which means cut off by 2 points, called an endpoint. Okay, so I want you to kind of create some geometry definition for array, collinear points, and coplanar points. So press pause and jot those down. So here are some fancy definitions that I came up with. We all know array has one endpoint and a line, so I started off with saying array is a part of a line, it's bounded by one endpoint, which means it starts with one endpoint and then is extending infinitely in one direction. Okay, so that would be a definition of array. Collinear points, the word linear means line, so I know I'm dealing with a line. Points, I know I'm dealing with points. And so the word co in this thing means same. Look at my fancy little slate. And so collinear points are points that are on the same line. Okay, so again, keyword there was point and line. So those were our two undefined terms that we use to define a term. Same thing with coplanar points. Coplanar points are points that lie on the same plane. Okay, so if I have a plane here and I have points all on that plane. All right, so I took the word point and I took the word plane, which are our basic undefined terms, and then created a defined term, coplanar points. Cool. It's probably not that cool. I know. Okay, moving on. Let's go down here, face. So after a term has been defined, so we just defined array, collinear points, and coplanar points. So after it's been defined, it can also be used to define other terms. So think of it like a family tree. You start out with, a family member, and then they have another family, and then they have families, and it just gets bigger and bigger and bigger. So, for example, an angle is defined as a figure formed by two rays with a common endpoint. So, again, we already defined the word ray, and so if I have a ray going this way and a ray going this way, I now have created an angle. So based on that undefined term, I was able to create a definition or a defined term for angle, right? All right, so I want you guys to try and define a term for complementary angles and supplementary angles. So we're seeing what you remember from your middle school days. A math tip over here, it says the common endpoint of the rays that form an angle is the vertex of the angle. So that's a fancy way of saying, hey, where your rays meet, that's the vertex. Okay. All right, so again, define A and B on your own sheet of paper, and then we'll go over the answer. Press pause. All right, so for a complementary angle, we have two angles. So again, we already defined the word angle, so we're able to use that again. They are two angles whose measurements have the sum of 90 degrees. And so remember, sum just means adds to. So for example, that's not a right angle. Let me go ahead and freeze that. Try that again. That looks like a 90-degree angle. So I have a 90-degree angle, and then it is two angles. So I have an angle up here, an angle down here, two angles that are going to add up to 90 degrees. And then down here we have supplementary angles. And so supplementary angles are two angles whose measure have the sum of 180 degrees. So for a visual picture, I would start with a straight line for 180 degrees, have a ray coming off of it, and I've got angle 1 over here, angle 2 over there. They create a straight line of 180 degrees. Okay, so I was able to define the word complementary based on my already defined term of an angle, etc. Okay? All right, guys. Let me know if you have any questions. Otherwise, we're going to move on to the algebra-y part of things.